Hi, I'm TJ. Welcome to my new video on Mastercam div. I don't know if we can call it a div or a case study. I'm not sure, but I think it is quite interesting. Okay, a few days ago, I received an email from one of my friends, and we talk about if we can use a STL model for a multi-axis toolpath, and yeah, that's cool. I have never tried it before. I never try using an STL model for machining because you know uh, the STL model is such a mess. You can do not you can do anything with this. You maybe very hard to modify or do anything with this. It's not like a surface or a solid like this. You can see this some kind of an STL data, and you can do nothing with this. So it's crazy. You can see it's a lot of point. Yeah, it's a mess. So yeah, we talk about if we can use the STL model for machining. Yeah, it's very easy with a 3-axis toolpath because you can see here we can select the dry surface for machining for a 3-axis. No problem, especially with the high speed, the new toolpath, the new high speed toolpath of Mastercam is not problem. But how about the multi-axis toolpath? Yeah, and I did some try on some multi-axis toolpath, and yeah, and I have some results that I think a few toolpath is not working with STL, especially the old toolpath, and I have tried the parallel, the morph, the flow, multi-surface, a long curve, and the triangular mesh, and a few work with STL and a few do not work with STL. So today in this video I just want to show you one toolpath that's working with STL. Okay, that's in the flow toolpath. I have another video on the flow toolpath, so you can check that video, and you can see how the flow toolpath work. Yeah, and in this video I'm gonna show you how we can use the multi-axis flow toolpath on the STL model. Okay, you can see on the screen I have an STL model of a human head. Yeah, it's scary. To me it's very scary. Wow, but it's nice. Okay, I will use this model for demonstration only. Okay, it may not practical, but for demonstration only. You can use any STL model you want. Okay, and this is the model. You can see with the STL model I can do anything with this. I cannot trim the surface. I am unable to do any surface operation or solid operation because that's not surface. That's not a setup surfaces, just STL. Yeah, just yes. Okay, so what we can do with this kind of this data. Okay, this model of a human head. You can see for example, you want to machine it on a 4-axis machine, and you mount the stock on a rotary table like this. You can see for example we have a cylinder stock, and we machine it using the indexing method. We rotate the stock, and we rough the part from 4 sides, from top, bottom, and front and left. So after we do the roughing, I have some rough operation here. You can see, and you can take a look on this. Yeah, there's some rough operation, and after the rough operation we have a stock like this, and B is ready for finish. Okay, this model has a lot of undercut area like this on the ear. Yeah, so you can see we have a lot of undercut area here on the ear or something, but as I told you before, this is just for demonstration only, so please don't care much about the the model. Okay, I just want to show you how the flow toolpath work on the STL model. Okay, and now this is the stock. This is the stock after the roughing operation, and it's ready for finishing. Okay, we will mount this stock on a rotator table with a 3 jaw chuck. Okay, and for finish we go to, yeah, of course you can do a 3-axis finish, no problem. This I would just want to show you how to use the multi-axis flow toolpath on a STL model. Okay, you go to the toolpath here, the multi-axis toolpath here, and you select the flow. Flow is one of the toolpath working with STL model. Okay, I select this flow here, and I got a 6mm ball mill for finishing. Okay, this is a long tool with taper shank. Okay, and here on the surfaces selection, I'm gonna click on the select button here. Okay, and there's one thing you need to remember. Okay, I can try to pick the STL model. You can see when I click on the model is not selected. You can see I'm unable to select the STL model. You can see when I click on this, it's not highlight. That means it's not selected. And when I do a overall selection like this, a box selection like this, yeah, it's not working. You can see I'm unable to select the STL model. Okay, and I also try to press the Control and A button on the keyboard, Control A to select all items. So you can see it's now highlight, but when I click on the Enter button or End selection here, you can see on the surfaces there is no surface selected. That means it's not work. We cannot select the STL model for the dry surface. That's crazy. So how we can do with this? Now how we can solve the problem? We can do nothing if we cannot select the surface. We cannot select the surface. You can see we cannot do it. Fuck. Okay, so but we have a tip here. There's one thing on the in the flow toolpath that's called the on the collision control. We have something that's called a compensation surface. Yeah, I will talk about this later, but this is a tip so it can help us to work with STL model. Okay, come on. So you can see when we use the flow toolpath, we can select the STL model for dry surface. Oh, I make some mistake with the toolpath, and now I have to regenerate it. Please wait a minute. Oh, come on, come on! I will pause the video a little bit. Okay, and I'm back. So you can see we have tried to select the flow multi-axis flow toolpath, but we are unable to select the STL for the tri surface. So what will we do next? Okay, you can see I have some level here, the STL for level number 1, and I have a level called number 2 for creating the tri surface. So now the next thing I'm gonna do is I will create a setup surface. So you can see the purple of this. Okay, I look from the left. I'll create a cylinder. Yeah, the diameter is not important. Okay, for example 20 millimeter, and I draw a line from here, yeah, to here, maybe the end of the STL model. Okay, and now I will make a surface using the sweep function. Okay, click on the profile and I select a line for the projection direction. Okay, so you can see I will mark it at green so you can easy to see. Okay, I will hide the STL so you can see this is a surface I created. I will use this for the flow toolpath. You can see the purple of this surface. Okay, I temporarily hide the STL part, and I'm back with the toolpath and the flow. Okay, now in the surface for the flow toolpath, I select the green surface I just selected. Okay, and I click on the end selection. Now you can see this is the direction, the flow direction. Okay, when I click on the cut direction here, it changed to cut like this. Yeah, around the part. Okay, I'm gonna use this direction for machining, so I click on OK, and on the cutting method I select spiral. For the detail on the flow toolpath, you can check my other video on flow toolpath. You will see what these parameters mean. Okay, on the tool axis control, I'm gonna select 2 point, and I select the point here. That means the tool will always point to this point. Okay, and I'm gonna select 4 axis, and the rotary axis will be the X axis here. So I select X. Okay, I think that's enough, and let's see what we have. Okay, oh, this toolpath keep dirty, so I can delete it. We don't need it anymore. Okay, just want to show you. Alright, I can turn on the stock. This is our stock. Okay, and now we have already created a tool. This tool. Okay, ping, ding, ding, ding. Yeah, now you can see we have a flow toolpath with the tool we selected. The flow toolpath on the dry surface we just created. Yeah, very simple. And the tip is now it's time for the tip. We're back to the level, and we turn on the STL part. Okay, so I think some of you will know what I'm gonna do. Okay, we back to the flow. As you can see, we cannot select the STL for the dry surface, so I have selected this green surface for the dry surface. So This green surface here will define the direction of the cut. This corner dry surface is define the direction of the cut. So if we don't want a rotary cut, we can click on the cut direction. So we have a axial cut. I'm gonna show you first the axial cut. What does mean? Okay. This is the axial cut. You can see it's follow the axis of the surface. Okay. Now we change it back to rotary by clicking on the cut direction. Ping, ping. Yeah, you can see the direction on the screen. And when you satisfy with this, click OK. Ping. Alright. Now this is the time for the tip. We go to the tool collision control here. Now you can see we have something called compensation surfaces. Yeah, this is the one we are talking about. Okay, you click on this button to select the compensation surface. Wow, you see that? It's allowed to select the STL. Okay, you can click on here, and now you can see when I move the mouse to the STL model, it change color. That means we can select it. Okay, click on this and it change color, and we click on the end selection. Yeah, you can see now it has been selected, and Mastercam allow us to select the STL for compensation surface. That's perfect. You can directly select the surface on the screen, or if you have another STL file on your computer, you can select cat file here and you browse to the STL file you want to select for compensation surface. Okay, I have the STL here right on the screen, so I select it directly. Okay, you can see we have selected it. Okay, now it's time. We have compensation surface and check surface. So what compensation surface mean? Actually I don't know what exactly what it mean, but you can imagine that it a set of surfaces that when you when the tool tip will contact with that surfaces. Okay, like this. We use the dry surface, this green surface, for define the cutting direction. And when we have the cutting direction, Mastercam will project the cut to the compensation surface, and this is what you got. We will regenerate the toolpath. Ping. Oh, just wait a little bit. Hello, how do you do? I'm here to be with you, and you, and you, and you. Some people say that Mastercam is stupid. Mastercam make me crazy. Fuck Mastercam. But you know what? What I think is, if the software is stupid, it will make you smarter. Yeah, it will make you more clever. It's make you more clever or cleverer. I don't know. More clever. More. It's make you smarter, more clever and better. So good people working with bad software and bad people working with good software. So yeah, just kidding, but when you're getting mad with Mastercam, just think about this. It makes us smarter. Yeah, smart people working with bad software. But in my opinion, Mastercam is not bad. It's very good. It's not about the software, it's about how you use it. Okay, now see that? Wow, 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 you can see that. Okay, this is how the compensation surface work. Mastercam create a cut using the dry surface and project the cut to the compensation surface, and you can see the tip is always contact with the compensation surface like this. Yeah, now you can see how we use the STL model, how we can work with the STL model in the flow 5-axis toolpath. This is only 4-axis, but this work. Now we do some simulation. Then this is the stock after the roughing operation, and now we do the finish cut. Choo. And okay, we will make a tool station. Okay, this is how this works. Make it faster. Okay, win, 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 win. This is how this works, right? Make it slower. Yeah, like this. Oh, that's not bad, right? Especially for statue engraving, yeah, modeling, machining is a good technique. I think this technique is cool, right? Make it fast. This is not a tool going. Okay, and this is for exit. We have some collision here. Crazy, but as I told you, this is just for demonstration only, so I will not go detail on, yeah, something not important. In this video I just want to show you how we can use the STL model for machining, okay, for creating a toolpath with the flow, multi-axis flow. Okay. Ooh, beautiful girl. Beautiful girl, beautiful girl. Okay, okay. Make it fast. And this one is just back from the battlefield, so he has some injury. Okay. All right. You see that? It look pretty cool, but look at this on the top of the head. You can see on the top of the head, we can see the step over here is very large. Yeah, because you know when we look from this direction, these here are a steep surface, so we have a very large step over here in 3D. Yeah, like this. I'm gonna show you. I will turn this on. Yeah, you can see on the steep area here, the step over is very large, because when we look from this, we have constant step over like this from here to here, constant. But when the surface is changed to shallow to steep, the step over become bigger like this. It's very large step over, so we don't have a nice surface finish there. Okay, and I will do another thing. Okay, we hide this STL. This is the first dry surface we use, but we can see when we use this the dry surface, because the step over is it distribute only along the x-axis. So when we have a steep surface, it will become like this, very large step over. Okay, so there's another tip to solve this problem. Okay, I will create another surface, maybe sorry, another level, maybe number 5, and then call that second dry surfaces. Okay, and now I hide this the old dry surface. You can now I make another dry surface. This time I don't make a cylinder. I will make something like this. I will turn this on. Okay. I also create another line from here. Maybe something around here. Okay. Now I can turn on this. Okay. I'm gonna offset this. Offset this line. Okay. Offset this line. Maybe yeah, 10 millimeter. Okay. And I create a circle with the diameter of 20. Okay. And I move this circle to here. Move, not copy. Okay, I move this to here. And ping. And I trim this. Okay, this is what I got. And what I'm gonna do next is creating a revolve surface. Okay, we go to the surface here and we click on the revolve. Where's the revolve? Cylinders. Oh wait a minute, I need to find a revolve. Okay, here's I'm gonna create a revolve surface. And then select the axis of revolve. Okay, so you can see this is another surface I created. A cylinder here and a sphere here, a half sphere here. Okay. And now I'm gonna copy this toolpath. Now you can see the difference. I will remove the compensation surface. Okay, first, so you can see what is the difference. I clear the old surfaces we have selected. Okay, I need to select it again. Okay, let's turn on the old dry surface. And we go to the toolpath. We have to unselect it. Okay. Now we turn it off and we're gonna select another surface. So now we have no dry surface. Now I can select this cylinder and this sphere. Okay, so you can see this in the cutting direction. Yeah, you can see on the sphere here, this step over now is constant distribution. Okay, I will show you how it works. Yeah, this is the toolpath when we don't use the compensation surface, the STL compensation surface. So you can see we have a constant step over. When we use a sphere here, a sphere surface here, we have a constant step over all over the surface. So now we turn on the human head, the STL of the human head here, and now I'm gonna select the compensation surface again. And ping, 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 and ping. Let's go. And you can see the difference, a big difference in the step over. Okay, I think you can understand why we have the difference. Okay, just wait a minute. hold on. Mastercam me crazy, but I love it. Okay, we have to wait. Okay, now it's done. The calculation is finished, and let's see that. Okay, look at this on a steep surface. So you can see what we have. Ting, ting, ting. You can see even on a steep surface, the step over is constant. Yeah, that's what I'm talking about. You see the difference? Yeah, because we create another sphere here, a small sphere. So when you project on a sphere, we have a more constant step over here on this area. It's not great, but yeah, it's better than this one. Okay, I can see it's much better. Okay, you can see the step over is more constant. Yeah, that's how the tri surface work. Level. So what happen if I have a bigger tri surface? Okay. Yeah, maybe try I will try a 40 the 40 diameter, so you can see a different. Okay, wait a minute, I will make it quick. Okay, I gotta make it quick. Right, wait a minute. Okay, we're gonna make another surface. Surface, and revolve. Ting and ping. Oh shit! Come on. This one. Okay. I'm gonna make a bigger dry surface, so it's close to the condensation surface. It's close to the sap of the condensation surface. So now I make another. I copy another toolpath. Choo choo. And I select the dry surface again. I don't select the small surface here. I select the big surface outside. Ping. Ping. Okay, and if we want to cut from outside to inside, we should select this. And if we want to cut from inside to outside, we click on the step direction. Yeah. Now I'm gonna cut from outside to inside. Okay, now we can see the difference. Well. We wait again. Bell, it's done. So take a look on this, and now you can see we have a better results compared to this one. You can see that. And when we use a bigger dry surface, that means when the sap of the you can see when the sap of the dry surface is close to the sap of the condensation surface, we have a more constant toolpath like this. It look better. And when we don't have the sphere, it look like this. And when we have the sphere, it look like this. So yeah, on this video I have shown you two tips. The first tip is how we can use the STL model on a 5-axis toolpath, especially the flow toolpath. Yeah, we can also use it on the multi-surface. I may show you on another video. I have also tried with parallel and morph, but not success. So I got some error message. So I will try this a few more time, and if I have any good result, I will let you know. At the moment, I cannot work with the morph or parallel. Yeah, it's not good. So the two tips today, the first is how you can use the STL model for 5-axis toolpath, the flow 5-axis toolpath. That's the tip is you can select the STL file for compensation surface. Yeah, like this. And we select another dry surface for defining the cutting direction. Yeah, and we select the STL for compensation surface. So the tool tip we can contact with, we keep contact with the the model. Okay, and the second tip is the dry surface creation. Okay, you can see here we have many ways to create a dry surface like this on the flow toolpath, but when you create a surface that's close to the shape of the compensation surfaces, you got a smooth toolpath and a constant step over toolpath like this. So you can see we use the dry surface to make the cutting direction, to make the flow, to make a smooth toolpath, and we only use the compensation surface for controlling the tooltip. Okay, so that's all today. I hope this can help you in some case, and I will try to work with other toolpath to see if any toolpath can work well with the STL model. Okay, if I found something interesting, I will let you know. Okay, thanks again, AD, who sent me this case study, and I'm very excited working with this. Okay, goodbye for now, and see you later in the next video. Okay.